Hello everyone, I am Ningaraj. I am explaining the COA assignment. Total there are 4 codes. First of all, I am explaining a factorial of a number. First, load the number. The number n is taken from the memory 60H and stored in a register R0. Check if number is 0. If n is equals to 0, directly store 1 in 61H since 0 factorial is equals to 1 and stop. Initialize result. Set R1 is equals to 1. This will hold the factorial result. Fourth step is multiply in loop. Multiply R1 into R0, store the result back into R1. Decrease R0 by 1. Repeat until R0 becomes 0. Store the final answer. Move the result from R1 into memory location R1 61H. Stop the program. Use short jump to keep the program further running further. So first we have to debug the program. Now we have to enter the number for the factorial. After that we have to run the program. So here we get the final answer of the factorial of a number. Here is our second program called find GCD. First the program begins at address 00H and jumps to the label start. Two numbers are stored in the memory. 62H is equal to 48, 63H is equal to 14. The program calls the subroutine named GCD underscore sub to calculate the GCD. SJMP means stop the program, infinite loop. Move numbers into registers. R0 is equal to 48, R1 is equal to 18. Subtract R1 from R0. That is A is equal to R0 from R0 minus R1. If R0 is equal to R1, step GCD found. Stop GCD found. If R0 is less than R1, swap and subtract the other way. If R0 is greater than R1, replace R0 with R0 minus R1. Repeat the loop again. If R1 is greater than R0, replace the R1 with the R1 minus R0. Go back to the loop. When both numbers become equal, that number is the GCD. Store it in memory location 64H and return to the main program. Total in brief, load the numbers into R0 and R1, subtract smaller from larger repeatedly. When both are equal, store result in 64H. So we come to the execution. When we have to first debug the code. After debugging, we have to enter the values. After entering, we have to run the program. So we get the final output of our code. Here is our third code to find the sum of a square of the first n natural numbers where n is stored at a memory location 67H and the result is stored at a 68H and also in 69H. So here is the code explanation. Start the program. The program begins at the address 000H and jumps to the main part. Get the value of n. Take the number from 67H, that's n, to R5. This will count how many times the loop runs. Initialize starting values. Set R3 is equals to 1. This is the first number to square. Clear 68H and 69H. Make the sum is equals to 0. Check if n is equal to 0. If the n is 0, skip the loop and go to the end. Result will remain 0. Start the loop. Multiple R3 into R3. This gives you the square of the number. The result is 16-bit, low byte in A, high byte in B. And the square to the total sum. Add the low byte to 68H. Add the high byte plus and carry to the 69H. Increase the counter. Increases R3 by 1. Next number. Decrease R5 by 1. One less number to do. If R5 is not equal to 0, go back to the loop. When done, when R5 is equal to 0, the loop stops. The final sum of squares is in 68H, where stores low byte, 69H, where stores the high byte. Stop the program. SJMP means a short jump. Keep the program stopped safely. So here is our execution part. First we have to debug it. After debugging, first we have to enter the where we have to up to where natural numbers we have to get this sum of the squares. After entering, we have to run it. So here is our output. Here is our last program. That is to find the square of a number. First start and load n. Move a 65H. Load the input number n from memory 65H into accumulator A. Move R2 comma A. Copy n integer into register R2. Clear 16-bit sum. Move R3 comma hashtag 00h. Low byte of running sum is equals to 0. Move R4 comma hashtag 00h. High byte of running sum is equals to 0. Prepare a loop counter. Move A comma R2 divided by move R5 comma A. Set R5 is equals to n. R5 will count how many times we add. JZ store result. If n is equals to 0, skip the loop and store 0. Since 0 square is equals to 0. Loop, add n to the 16-bit sum n times. Move A comma R3 or add A comma R2. Add a low byte of n to the low byte of sum, result in A. Move R3 comma A. Store a new low byte of sum. Move A comma R4 or add carry A comma hashtag 00h. Add carry from a low byte add into the high byte of a sum. Move R4 comma A. Store a new high byte of a sum. DJNZ R5 comma loop underscore add. Decrement R5. If not 0, repeat. This makes the addition happen exactly n times. Store final 16-bit result. Store underscore result. Move 66h comma R3. Store low byte of result at 66h. Move 67h comma R4. Store high byte of result at 67h. Stop. SJMP dollar. Infinite loop to the halt program. So here is execution. First we have to debug it. After debugging, we have to enter a number for a square. Like example, we have entered the 5. After entering, we have to run it. So here is the 19h, which was in hexadecimal. After converting it into normal numbers, it gives the correct answer. So thank you.